2 years ago, I was teaching an 8th grade math class, and we were going over the rules about the angles of a triangle. And one of the rules is the sum of the three angles of a triangle, angle A plus B plus C, will always be 180 degrees no matter what the shape of the triangle. So we were working on that when one of the students asked me, why? Why does that work? How do you know it's always true? She said, can you prove it? And I thought about it and I said, I don't know. I don't know why it works. I cannot prove it to you. So then I had to go and find out what that proof was. I did some research on the internet, found out on Wikipedia that in 300 BC there was this guy who solved it, Euclid of Alexandria, and he was named the father of geometry. And here's Euclid teaching in the squares of the city of Alexandria with his students. So, a little more research, and I went to the website called Wiki Pages, and I came up with Euclid's solution. And here it is. Right there, it's laid out, it's step by step on Wiki Pages. So I'm going to explain that to you now. First, we need to understand something about intersecting lines. Intersecting straight lines, these angles, four angles formed by the intersecting lines, adjacent angles, angles beside each other, are going to add up to 180 degrees because it's a straight line. This one has to be 110. If we go in this direction, these two also must add up to 180. So this next one has to be 70. If we go down, back down this way, we see the third angle has got to be 110. And then we finish the loop around the circle. These last two, 110 and 70, must add up to 180. Notice also that these opposite angles in this set of four, the opposite angles are equal. So now let's look at three intersecting lines. And something similar happens. If this is a straight line with two intersectors, then these three angles must add up to 180 degrees. So angle A plus angle B plus angle C must add to 180. Why? Because when you stick them beside each other, they form this straight line, line L. Alright, next we talk about parallel lines. If we have a diagram with two parallel lines, then we know line L and line M, and line L is parallel to line M. That means that all points along both lines are the same distance apart, and we have a line that is intersecting each one. Then we know that
if you are a student staying to either work on your
this angle that is corresponding to the 70 degree angle is equal to 70 degrees. And also, since we know the opposite angles are equal, then this angle opposite it must be equal to 70 degrees. So these two angles that are both inside the parallel lines and on opposite side of the intersector are equal to each other. Now, if we add another set to this and line it up, hold it, give me a second to line it up. There we go. We bring another intersector across, and this one is intersecting at 50 degrees. Then we can see that this 50 degree angle here is reproduced down here, and that angle corresponds to the first one at 50 degrees, and then these two are opposite to each other, so that this one is 50 degrees. So now we're seeing that these three angles, one is 50, one is 70, they add up to 120, so we know this one must be 60, and therefore these other two angles that we previously proved equal to these guys up top are 50 and 70 as well, so those three angles must add to 180. So that works for these, for angles of 70, 60, and 50. Will it work for all angles? Well, let's just try that. Let's put this one out here, and here we have two parallel lines, one intersector. This time this angle is going to be called B. And if this is angle B here, then down here, and this angle which corresponds to it, because these two sets of four angles match, this is equal to angle B, and we also know that this will be B because it's opposite of B. And so we know that these two angles that are inside the parallel lines and opposite sides of the intersector are equal to each other. And now let's bring in another intersection, and let me just line this up for you. Alrighty, so here we go. With that second intersector coming across, it forms this angle C. This angle C also corresponds to this angle C down here, and just like in the other cases, the opposite angle C is there on the inside of the triangle. So if we label this angle up here A, we know that A, B, and C up here must be 180 because they form a straight line. But look these are the same three angles we were looking at the beginning. Angle A plus angle B plus angle C equals 180 degrees. And there is the proof for any shaped triangle, thanks to Euclid and these clear plastic pieces of paper. Goodbye.